So the short version of how we use the entire thing about edge regular lattices is that imagine you start in a world and then you do a little bit of exploration. It could be like, for example, you could do things like, I'm here, let me try an action, and now, or like, let me try all pairs of action, and then see like, oh, maybe some of these actions inverse. In a grid world, that would be true. Sort of you can do that kind of thing, and then you get some information, and you can explore more, and then you can be like, oh yeah, maybe this is like some grid structure, or like you can discover that. Like even in this simple case, you could just do random stuff. Yeah, you just keep this, you just generate a graph, you keep it in memory. You just like generate this graph, and you have it. Like you just remember it. And right now we're assuming you perfectly observe the environment state. So let's assume like we're just like, here's the environment state, I can do this, now I'm here, I can do this, now I'm here. You do a bunch of exploration, at some point it will just be, like that seems pretty easy, you will notice, oh like, yeah, if I do like this action and this action, this action, and this action or something, like then I go back to the original state. And you sort of build up this sort of graph and connect it. And then you have an algorithm that can check if something is a lattice. And then it's like, oh, it's a lattice, right? That's not hard. So now we know we are in a lattice. And it's like, oh, but it's not an edge regular lattice, weird. Now we could do something like use Matteo's algorithm that would make it such that we have sort of higher level actions in the sense that we sort of like now not think about what is the action label on this edge, but we would think of it as, or like in the simplest way, you could think of it as like we label the edges now with the deltas that they cause instead of with the action names. And now we can ask, are these environment deltas regular? And then Matteo's algorithm would go further a bit and would also like find the mapping that is sort of like small and efficient and a complete naive thing of if we have this delta and we want to cause this delta, what's the action that we need to do? That means now we can plan with the deltas in this graph, or like now, okay, now we have sort of this thing where we know it's an edge regular lattice. An edge regular lattice can be really easily modeled with a very small model that's really efficient. Like you only need to store that for any vertex, what's the delta in this case, the environment delta that goes up, what's the one that goes right, what's the one that goes left or down, or like for like, you need to save like these two n deltas if you have an n-dimensional edge regular lattice graph.
Okay, I think it's super helpful.
Nice, and then this is a really small representation. I didn't explain it, but then there is some algorithm that can plan in this and generate plans that's also like pretty efficient. And therefore, we sort of, what we have done is sort of like we introspected, or like introspective, we like explored, we did a bit of science sort of on the environment, or like, like what we did is we looked at a bunch of things and then we were analyzing the structure sort of the transitions that would happen in this space and made a model out of this kind of structure that is like sort of a good efficient model. And this model is now, because it's also really fast and really small, we can also now use it for planning, meaning that if the world is actually like this, we have the algorithm that can first explore and generate a sort of data structure of a graph, then 2, check whether this is actually a sort of lattice graph. 3, does sort of a simple transformation on this. Well, there are multiple of these things that you can do, and Matteo's algorithm is one of them, where you could sort of transform a lattice graph into an edge regular lattice graph, because sometimes you can do that. That's what we did now here. Then edge regular lattice graph, really easy to make a model of. So we make the model of it.
Yeah.
And then, also we have a planning algorithm which writes an edge regular lattice graph. Now we can use it to efficiently plan to reach any state. So this is a very specific setup that works if the world is an edge regular lattice in the sense, but it might not be in the actions, but it needs to be in the environment deltas. So it doesn't actually need the entire graph to be, but it's like, now we have this kind of entire algorithm, all of these steps, and we can execute this when we are like somewhere in the world, and we can notice that we are in some lattice, sort of edge regular lattice structure. And even if some environment part is like not there, we can still figure out that the model is here, or like it's sort of easy to then like check, or like how big is this model, how large is the lattice, even if it stops at some point. And then you sort of know how to navigate that part of the environment. Yeah, right now we assume we just reached the world state. We just observe the world state in some sort of structured way. But I mean, what we need for this entire thing to work, such that we also can plan, is that between these two world states, we can check if they're equal, and we can compute the delta of these in some meaningful way. And we know we can associate, but this is kind of the same, I guess. We can associate an action with a delta. And that's all we need to plan. We don't actually need to understand sort of in any deeper way what does anything represent in here. We only need these operations. And I guess like the thing that is sort of still implicit is we also need to be able to all of the deltas, we need to be able to compute for the deltas that we have, how would they combine to form the target environment, or like the offset, the delta from the current environment to the target environment. How can I combine all of these effects that I can have, all of these deltas, such that I build out of my current environment the target environment?